The freshly baked buns travel onto this massive spiral conveyor, cooling rapidly in the chilled air before packaging.
The cooled buns align into single files as they approach the high-speed slicing station. Circular saw blades
In the liquid processing area, massive stainless steel tanks are filled with oil, vinegar, and water via automated overhead pipes.
Here in the cold processing room, raw chicken breasts are rapidly moved along the sanitized conveyor belt, maintaining strict cold chain integrity.
The chicken breasts pass under a laser-guided vision system that identifies fat and irregular shapes.
The uniform cutlets travel to a multi-needle injector, hundreds of hypodermic needles descending rhythmically into the meat, injecting a spicy brine solution.
The coated chicken fillets emerge from the breader onto a wire mesh conveyor belt. A slow pan captures
The toasted bottom buns move into the dressing station. Automated nozzles swirl.
A second dispenser applies a light layer of cool mayonnaise to the underside of the crown, ensuring moisture in every bite.
A second dispenser applies a light layer of cool mayonnaise to the underside of the crown, ensuring moisture in every bite. At the wrapping station, distinct sheets of foil-lined paper are fed individually onto the belt. A macro...
The wet conveyor moves the potatoes under high-pressure air knives, blasting away the remaining water before they enter the peeling chamber.
The potatoes enter the steam peeling chamber, where rapid bursts of high-temperature steam loosen the skins instantly, ensuring maximum efficiency.
Temperature holding steady at 190.
Acknowledged. Flow rate is optimal.
The flow rate is slightly high on the left side. Adjusting it now, keep an eye on the temperature.
Vibration levels are stable across the board.
Confirmed.
Confirmed. The oil separation rate is optimal.
The flow rate on belt 3 is slightly high.
Yes, the distribution variance is trending up. We should adjust the vibrator speed.
This one looks good. Temperature is stable. Keep an eye on the next batch. I saw a slight bulge earlier. Tension looks good on this side.
Full coverage confirmed.
Scan complete on pallet 9.
Confirmed. Route to Section 4.
That's the correct sensor assemble.
Acknowledged. Finalizing the request now.
According to the schematic, this nozzle requires calibration.
All right, let's adjust the flow rate.
Keep an eye on the pressure gauge in Sector 4.
It's stabilizing now, Supervisor. Output is steady.
Check the voltage on line 3.
Reading stable at 480. Looks good.
All right, let's move to the next bank.
Sequence initiated. All systems green.
Confirmed. Pressure stabilizing at nominal levels.
We are fully online. Good work, team.
The synchronization is holding at high RPM.
Deceleration sequence initiated. Readings are consistent across the board.
The temperature on Fryer 7 is stable.
Noted. The arm alignments look good from here.
The density in this section is remarkable.
Yeah. Yes, the crystallization pattern is exactly what we need for the extra crunch.
There's the failure point. 250 newtons exactly.
The seal integrity held up well until the final compression. The pressure spike on the hologram aligns exactly with the impact.
Yes, but the seal integrity held up perfectly.
These platforms simulate the intense vibrations of long-haul transport, crucial for ensuring the integrity of the packaging.
The alignment scan looks good here. Yes, the calibration seems accurate since the update.
As you can see on the workflow chart, our Q3 efficiency improved by 10%.
Building on that success, inventory levels on line 3 are dropping faster than projected right here.
Understood. I'm rerouting the next shipment from the auxiliary warehouse now.
We have a slight misalignment on the upper helix.
Copy that. I'll schedule an adjustment for the next cycle.
The thermal reading on plate 3 is stabilizing.
Yes, the moisture curve looks consistent with the last batch.
The turbulence on the right side is still too high.
Let's increase the pressure slightly and rerun the smoke test.
The uniformity on line 3 is deviating. Check the calibration on the Z-scanner. It might be overheating.
All right, team. Ensure the tension rollers are fully disengaged before we lift the frame.
Got it, instructor.
The grip tension is holding steady at 1.2 newtons.
Perfect. The adjustment worked. No crimping on the seal.
The oscillation peak at 40 Hertz is slightly higher than the baseline.
Yes, but the dampening effect is stabilizing it within.
Looks good. All pressures holding steady.
Confirmed. We are well within the acceptable range.
Duration. The audio is dominated by the sounds of industrial machinery operating smoothly.
Check the timer readout on the fryer.
Inputting the data now. Response time was 0.2 seconds.
Main power restored. Check screens for errors.
Systems booting up. Commencing robotic calibration sequence now.
The internal temperature is stabilized across the pallet.
Confirmed. We are cleared for transport.
See this data spike right here? That indicates load shifting during the vibration test.
Understood. It failed.
Check 1, check 2. Testing the microphone array. Over.
Signal is strong and clear. Confirmed.
The tension looks good on row 3.
Clear labels, everything aligned.
Ready for sign off.
Bay 4 is clear. Send the next unit in.
Confirmed. Bay 7 alignment underway.
We had a brief conveyor stoppage on the east side, but it's clear now. Fryer temps are stable.
All right, I'll keep an eye on the throughput for the next hour. The gauge is holding steady right where we want it.
Perfect. The consistency on this batch is excellent.
The calibration levels are optimal across the grid.
Acknowledged. We are clear for activation.
Keep moving. Stay in formation. We need to beat the last time.
Here in the light tunnel, the chips undergo rigorous spectral analysis.
We're looking for any deviation from that perfect golden hue.
Look at the vortex pattern here on Sector 4.
Yes, definitely a pressure drop at the seal.
Here in the quality lab, we use the density measurement drum to calculate the precise mass-to-volume ratio of the chip samples as they gently tumble.
Batch count confirmed at 45,000.
Noted. Moving to the next pallet.
The impact stress on the seal integrity is lower than projected.
Rerun the sequence at 900 FPS to confirm the shear angle.